So I'm not sure of using this, but in case you haven't, let me go over all the code quickly, and then after that, I'll answer some questions, and then that's class dismissed. Yeah, so sorry for like the unorganized today. The teacher wasn't able to make it, and her announcements was a bit late. So let's start with the code right here, okay? So this is, everybody knows what and this is what the player, this is the code for the player, right? So let's look at some of the code player. This game seems to be a platform game, by understanding. And before we start anything else, let's go through the game and take a look at what exactly it does. Okay. Okay, so as you can see here, this platform game is just a scrolling path game where each sprite moves and it moves from one side of the screen to the other. So in this case, from this side of the screen to the side of the screen, and the player has to jump in order to get from one platform to the other without falling. And obviously, if you lose, there is a game over, and if you win, there's a you win sign. Now let's take a look at the code for the player to see exactly like what these functions. So let's see. So when it's clicked, so when we click the flag, it goes to the front layer. And the front layer sprite pops. This becomes the first. The sprite. How should I explain this? So basically, think of it this way: this background has layers, right? And each layer overlaps over one another. For example, if I were to do the sprite over this block right here, it would go over the block and it would disappear behind, right? For example, if I were to take purple block here, which would put it over the sprite, it's not gonna go over the sprite when I release them. It's gonna go behind the sprite. Okay, all right. So when I release them out, click the flag button, supposedly should go behind the block, right? That's what front means. And then, as you can hear, it goes to certain coordinates. For example, this goes to x negative 95 and negative 25, which is right here. And it would change its y by -1, which basically means it would just down very slowly until it touches the platform. And when it's the platform, it would stop. So let's look at that. The screen doesn't move until it touches the platform. And let me find where that is. So as you can see here, let me pull it up that. It is still falling because it hasn't touched the platform yet, right? It says if not touching platform. It hasn't touched the platform yet. Because it hasn't touched the platform yet, it's still continuing. Now, if it touches the platform and the up arrow is pressed, then it would go by 100. So in this case, it won't like this and then go back down. It will up 100, right? This is something that I personally change. I would try to like change y by 50, by 40, then 30, by 20, and 10, and then this makes the jump a little bit realistic. And let me show you how it works quickly. So if you want to do something like a realistic jump, we want to have at least 5 change steps. Oh, whoops, this is moving. Sorry. Road. Change y. You will want at least 5 of these, and then you would want, where is it? Right here, you want to wait 1 second, right? Block, because you don't want, because if you were to put all these, there will be no difference in time when you do it. So like, for instance, in this, if we were to put the block like this, right here, instead of up slowly, bring up 100 first, then going up by 10, it would just go up instantly at the total of all of these, right? So think about it like, if it goes 100, it would go to the next, it will go to this block. It won't have any stop in between, right? And the problem with this code, right? So what we have to, in this case, is take our wait 1 second and we put in between each to create a little bit of rhythm, right? Now we want the sprite to wait 1 second at each turn. All right, that's a bit too weird. Like if here, right? If you were to take a look right here, it won't jump at all, right? Because it's the waiting 1 second, and by waiting, so changing its way, and that glitches out, and then you can't really execute the 0. We got a short amount of time first to make a lot more realistic. Generally, I prefer to make the time increasing. That way, it looks a lot more realistic. And secondly, sorry, you also want to, okay, so you also want to decrease the distance. Like that. So then after you get to that point, what you want, hold on. Up arrow, right? So this way, while you do it, like that, right? Now, because of this, we can turn the time a little bit. I think we were waiting a bit too long. So this is where you can do experimentation. Take a look how quickly you want to position the timing so it looks realistic. Jenny, you want it to be a little short. Okay, like that. It's a bit more realistic, but I think we're better, right? Now, this is where it gets a little bit complicated. So the good thing about Scrap, you can kind of adjust the code as you go, and the blocks are intuitive enough that you could do some pretty easily. So let's do repeat, right? And we want to repeat this out maybe 30 times, right? Last time I showed you it would decrease its distance 5 times, which basically means go up once, twice, 3 times, 4 times, and then 5 times, and then that's it. If we want to do something better, all we can do is have it go a lot of times. It's like it's going really smoothly. So by the time I finish making this code, you would see that this block would go like this instead of this, right? And then that way we can make a realistic jump. And I'll show you how to make this a little bit more realistic as we go on through this lesson. But generally that is the concept, right? You want to have as many little jumps as possible, very, very little. And in this way you make those little really big in the end because you put them all together. So let me show you how that works. So you're using a repeat, which I hope the teacher has now. There won't be any have so many change by or wait. It's just like that. Now just put it there like now. As you can see, it's really changing. Right? And in order to change that, we must use what's known as a variable. So in case the teacher hasn't told you about this yet, a variable is like a box. Think of it like a box. With this box, you can put whatever you want would store it. It would store whatever's inside it, right? Just like how you would put a book box, but the box would store the book, right? So, right, let's make a variable. So let's call it, let's say let's do jump, the jump variable, right? This jump variable, it can actually in a lot of places. Now I'm going to show you places it can go in, but generally speaking, any scratch block that's this little circle can fit one of the variables. Not all variables fit in can fit anything, and not everything can fit variables. As you can see here, it doesn't fit a variable, right? And let's see, I believe this one also doesn't fit a variable, right? But does variable. Now, this to be in, you could have different variables, and you can have variables for different types of blocks, and for different types of blocks, you certain things inside the variable. For example, if you're to bring a box to a science teacher and you open it and the science teacher opens it up, only find, let's say, a lunch, right? That wouldn't make sense. And the teacher won't understand why you brought her a box with a lunch when she's a science teacher, right? So in case, maybe bring her a vial, right? Or some kind of fluid, right? That might make sense to give scientific teacher. And this all applies to variable here. So let's see what would happen if I were to put jump here and I would set jump hello, right? Since the block has changed y, with that right here, as you can see right here, since this block has changed y, it needs a number for it to do something. As this variable, so I put hello in the box, and change y by opens this box, and they take a look at and they realize that the variable is hello. They won't really understand what exactly they're supposed to do. So let me show you, nothing would actually happen. Right, as you can see, nothing's that happening because this used. It's not sure what this is supposed to mean because this hello and change y by needs a number. So in order for this to work, we have to have a number. Say number is by, right? Now, if you can see here, it will be change y by jump, which jump is 50, right? So now we do it, right? Jump by 50. Now, this actually jumps 30 times, and I actually want that, but for now, we'll keep it because as I'll show you soon, I'm gonna need a lot of repeats. After changed, right? After this has moved 50, we want it to slow down, right? As you want to jump, when something jumps, it doesn't jump like that, right? It doesn't continue at speed. It slows down a little bit and goes right back down, right? So what we want to here is, let's see, we want the variable, we lower the amount of distance that this block goes, right? So let's say we change jump by -1, right? Now this is where it's there's a little bit more math to it, but if you think about it this way, 30 minus 1 is 29, right? So change y by jump would mean after, let's go through this from the start. Is 30. So we know that change y by equals 30 at first, right? Then goes into this repeat block, right? Y by jump equal change by 30 because we set it to 30. Now what by -1? That means we can jump from -30 to 29. So now you go back, then change y by jump equal 29, not 30. So let's see in action. Like that. It is still a bit fast. So what we want to do, we want to lower this number until you feel like it actually shows a realistic, like that. As you can see right there, did you see that? Right? You can see that the realistic jump there. Now there's still some buttons. For example, we need to repeat until it touches the platform. Instead, let me duplicate that. Instead of just going on for it, because we all know if it goes hold on. Like if it's under this platform, it's over, right? And we don't want that to happen. So what we want to do is for a jump until to the platform, which is the point, right? So let's see that again. Oops. Okay, hold on. Okay. Okay, so this is like the wrong block. So give me a quick sec. Yeah. I'm not sure I've used this block yet, but this is the rip until block. So this block now makes it so when you change y by jump, it will all repeat. It would continue and until something happens. In this case, we want it to continue until the sprite is touching the platform. So let's take a look at that in action. Okay. Okay, so I think this should work. Yeah, like that, right? As you can see, it would now jump realistically. Now it's still a bit janky and you can still do some stuff to it, right? Like that. Still a bit not quite right, but just it teleporting up 100, then going back down, right? So now what we want to do is we want to lower this a little bit because by lowering this, it changes a bit slower. So now if we test it out, it actually jumps higher. But now, as you can see, it's a lot more smooth, right? Now this is a bit too personally prefer to keep it at -1. And it's something, this is just experimentation, right? And this is, I'm just gonna put it out there for everybody. For ways you can be a programmer, but the most important thing of being a programmer is problem solving, right? You got to be able to look at a problem and say, okay, so I'm looking at this problem, but I'm not exactly sure what. What do I need to do to make this right? Right? In my case, as you can see, my process, I took a look at this, right? I took a look at this and I thought, okay, so it's not being realistically enough. What makes a jump realistic? Then I go, now what could I do to these blocks to make it realistic? And then lastly, I would go, now that it looks realistic, is there anything I can improve? Or is there anything I should note not to do in the future, right? So that's just a quick lesson for everybody. Just make sure that as a programmer, whether it's on Scratch or if it's on anywhere else, you need to make sure that you're always problem solving. You're problem solving. You're looking at any problem and you're trying to solve it, because whenever you create a new Scratch project, no matter what exactly you do, you're going to come across a situation where something's not exactly right? Never blame this on the computer, but problem solving is one of the best tools you would have in trying to solve something and trying to get over issues like these, right? Well, let me show you once again, right? So this is actually how we would do, so back to the jump. This is how you would do a realistic jump. Let's take a look at specifically at what I did, right? First, we are using variables, right? To everyone that isn't aware of it yet, variables are like boxes that you can put whatever you want in, right? However, you can't just put whatever you want and expect it to work, right? Certain blocks need certain, what we call input, just the thing that is inside the box that the block would use, right? Now, in this case, change y by needs a number. It cannot take anything but a number. So if we were to change this to something below, change y by wouldn't work because change y by needs a number, not a word, right? So in this case, I put 15, right? Now, 15 means it'll be going up 15, up by 15, right? Now, as a variable, this will do the exact same thing. Hold on. This will do the exact same thing. There is no difference between this and just having 15 down because jump is also 15. So, you know, figure everything goes through and change y by jump is 15. So then change y is by 15. Now, we go down more. Well, I actually change variable. So I'm not sure if I mentioned this before, but I can change the variable at any point of the code. I can change the variable here. I can change the variable here, change the variable here. I can change it here, right? But it will change the variable, right? Now that I'm changing the variable, let's take a look at this block itself to see what exactly I'm doing by changing this variable. I'm changing jump by -1, which means that this jump is going to go down by 1 in the next line of code, right? So in this case, if I'm jumping -1, right? Jumping by -1, then we go right back because the repeat block, remember, right? This is going back to repeat and we change y by jump. Now jump, remember I changed jump -1 using this block. Now that means this block is now 14, right? So that means that now instead of change y by what jump was, change y by is now 14. The computer does all this really quickly. And because it does it really quickly, it makes it look like this thing is jumping, right? And it looks like it's just jumping as you, right? It looks like it's jumping, which makes sense, right? It kind of is jump. That's what we want it to do. But now that it's jumping in rather than just going up by 100, and because that's not realistic and that's not what makes a good game in Scratch, right? You could do a lot with Scratch, surprisingly. Now, for this one, now we want to talk about how the fling should work. Now, just a question out there. This is, you don't have to answer it, but everybody fall like this? No, right? Nobody falls just going like slow drifting down like a balloon, right? It falls like that. When we all fall, we always fall like this, right? We start slow and get fast, right? And based on how I can apply, I can do the exact same thing to make this start slow, get fast. This is repeating until touching the platform, right? Now, what we want to do is create another variable here. Let's call it fall, right? Now, this fall variable we're using to make this fall. So let's put this and change y by. So we need it to move, and in order for it to move, we need to change y by, right? Let's set to 0 for now, right? So let's set fall 0, right? And as you can see, the statement here. Right? So we need anything more than just if not to platform. So let's use the same repeat until. Okay, this because right. So repeat until to platform. So what this does is the computer will look at if this right here is touching the platform, and if it isn't the platform, put a repeat. It will put a repeat block until it actually touches the platform. Until it actually touches the platform, right? So if we were to change y by fall, and we set fall by 0, like that, we don't affect this thing. Because you can see if we were to put this like this, right? And then we could do the same change y by. Now we put the change variable by -1, right? Every time it realizes it's not touching the platform, it sets to 0, right? That and going like this. Just the same speed gap, like just loading gap, right? Which is what we want. We want it to go. We want it faster slowly, right? So what we have a repeat till, and we've been here, and we set fall outside, right? Because we're waiting, because this block will repeat until it touches the platform. So until it touches platform, not set fall 0, and that's what we don't want it to set to 0, because we want it to get faster, not go to 0 every time. If we were to put this back where it is, right? Now when it falls, it should, hold on. Yeah, so it should right now. So it's a bit fast. As you can see, it's a bit fast. So we can make it go a little bit. So let's do it this way. Right, so now I can jump, and let's take a look. So see, it's still a bit too fast. So let's make it 0.25. Right? That way it's not too fast. Let's take a look again. Like that, right? So as you can see, it fell, and it went from a little bit, from a gradual, then it went faster. Now here, it's still going really slow at the start, and we don't want that. We still want it to fall down like it would a normal person. So let's find the code, and the code's right here. All right, so this is the code right here, right? And what we want to do now is we want to take this out. We want to do this. We want to duplicate it, and we put it here. Now, what this does essentially is as what I showed you earlier, but now it would do it in two at the start, right? And whenever we're not touching a platform. So let's show that. Okay. Touching platform. Okay. Let's try now. Hold on. Something's... Okay. So now, as you can see, it works. Even if it's touching the ground, it will go up, right? So the problem before was that it wouldn't go up, even it wouldn't, even if I press up arrow key. Now, when I do it, it jumps, right? So that's another point for like the problem solving thing. So everybody, right? So when this kinds of, you gotta understand that, okay, so this is a problem, we need to figure out a solution. Anyways, then you can see It is falling a bit slower now, right? Still falling slow, but it's realistic. It's how everybody falls. You can get more crazy than this. You can, do you can do all crazies with this and try to figure out, oh, such and such and such. But this is good enough to solve this game realistic, right? So honestly, okay, so let's look at some of the other ones. So let's take a look at purple sprite, right? So let me stop. Hold on. It's a bit too late. Okay. Stopping a bit too late. Okay. Give me a quick. Okay. Oh, hold on. Shoot. Right here. Oh. So this is good costumes. We see that there's a green square right here. Now that green square is any green square lying there. When we touch that green square, right? That green is there for. Now it says right here in the code, when we touch color green, right? When it is green, when there is touching the green, we win, right? And it shows that by showing exact same color as this square. All right, so this square's color is the same as this color. This sprite touches this color. It realizes, oh, okay, so I'm doing this color, which is this square, right? And once it touches that color, well, I'm gonna broadcast win, right? Now, when it receives win, right here, in this block right here, stop all the others in this sprite, right? Which means every single line of code stop, right? Now it doesn't mean it'll affect other sprites, but it will have its own sprite. So everything in, right, is in little sprites code, it would stop. Everything would stop, all right? And for this piece of code, when it receives win, it switches costume to the win sign. Right, so that's the column's name, win. Right. And then it would show, because originally hide, as we can see here, and it would go to the very front. Like I said, the front might seem a bit confusing because layer is a bit confusing for codes like this, but it will go to the front, and by going front, it goes past everything else. As you can see right here, they're all behind this, right? This thing is opaque, which means that this thing will in front of everything, and you won't see anything behind it, right? And after it goes to the front layer, stop everything, right? So for types of stop, right? There are this script, there's stop scripts, and then lastly, there's stop all. Stop all means all rights code, including the ones here, will stop, right? Because this game has ended, we want to stop all scripts, so we use the stop all. Now, let's take a look a little more confused algorithm here. Is this one, right? To a couple people probably. So let me just dive into this and just explain how exactly this works. So if color red is in color purple, or it is in edge, then broadcast lose. So now we know whatever happens here, this loses, right? So let's see what exact colors they're talking about, right? So the color of the red is the top part of the sprite. So our intentionally created this sprite so that there are two colors, and making two colors, since one is above the other, right? As you can see, right, one is above the other. We can make it this part, as long as it goes below the purple as long as it goes below purple to the point where this is touching the purple is right, the purple thing, and we, right, in this case, you can't do any once you get kind of purple, so you lose. And however, since there's a little bit of black here, every time you land on the platform, that would not mean you lose. After this whole thing move low here, that you lose. Okay. So see, okay. So like that, right? So that's what the color red is touching color purple mean, right? So let's just take this away here. So now this sprite, right, touches this, it's not going to lose. If it touches right, now the game has stopped, right? It's not going to actually follow through. But you can see when I play the game again, that will happen, right? And okay, so let's talk about the last piece of here, which is the touching edge. Since it is the edge, right? Now, if it says touch edge, that means the red's touching the edge, it loses. No, if the whole sprite touches the edge, it loses. It doesn't matter how sprite touches the edge. Touches that in any way, it loses. Okay? So let's show you that. Oh, hold on, something's not right. Oh, bless you. Okay, so let's take a look right. Is anyone there okay? Okay, so as you can see right here, the minute it touches right here, it loses, right? And that's because the red touches the purple, not the blue, not the black, sorry, right? As you can see right here, it's not touching the black, right? So that's about all there is to it. I'm going to quickly explain this platform, and I'm going to end the class by giving everybody a little bit of tips on their journey through Scratch, because what we are covering today is not nearly everything that Scratch has to offer. But with these tips, you could be able to start your journey to self-discovering all these different blocks. But in general, there will be a couple tips that you guys can use in your journey in discovering Scratch, right? Many Scratch users actually discover Scratch just by themselves. And even if we don't thoroughly teach all of these blocks, which of course, I'm not sure if all of you are equipped to understand all of them, but you soon will, right? And with these tips, you can continue your journey and be a lot better at Scratch on your own time without the need for. And okay, so let's take a look at the purple platforms. So when the thing is clicked, it will show, and it will go to the exact middle. So the middle is x equals 0 and y. The middle of any Scratch page is 0, 0. So it would go right here, right? Because the middle of this is here, right? And the middle of this sprite is around here. So it goes right here. And that's why it looks the way it is, right? Now, let's take a look at this, right? And it would go to layer, then it would go back one layer. So it goes very front, so nothing else is going to cover it, but then it goes layer back. Now this person right here, I was also went to the first layer. It would always go in front now, because this one's behind one layer, which means that this, this block right here will always go in front of this block, but this block will always go in front of everything else. All right. So now it will switch costumes to start. So let's take a look at the start costume. This is the start costume. Now it would switch the costume to start, which is, like I said, this costume, and then it would create a clone of itself, right? So now when it creates a clone of itself, it would go hide, right? Because this is X position is over negative 465. So this is a bit confusing to everyone, but basically how left or right is something, right? Now this is 0, 0, which means it's a lot bigger. It's a lot less than negative 465, right? That means this would hide, right? Like this one says. Now, when something starts as a clone, it would go to X equals 450. Now remember, like I said, X goes to 450 equals left, right? So 450 is probably somewhere around the right. I assume somewhere here, right? Where it's like pretty much not shown. And something in here is that it says when I start as a clone. Now, script right here, as you can see, it's create a clone of myself, right? Now, when it creates a clone of myself, this new clone is not necessarily a separate sprite, but it is technically a separate sprite. So this is a bit confusing. Just think of it like this. When it creates a clone, it's like if they duplicated this, right? But when they duplicated this, only this code, right? Now it says, when I start as a clone, switch costume to end, and then go to 450. So when I create a clone, it's like duplicating this and then deleting everything here. Like that, right? That's what's like when you create it, right? It's like duplicate sprite and only include this script, because what it does when I start a clone. So when you clone something, it doesn't clone every single script in that sprite. It clones this object, this thing right here. It clones that. The new clone doesn't have any. When I start clone, right? Because allows you to not duplicate it and then require delete all sprites but this. Right, delete that again. Go from 450 to 0, right? And when they receive start, which is switch costume to start, this gets weird and said and creates a forever chain, which basically says change X by -5. And if X position is negative 465, then basically what it's saying is it will start at 450. It will start at 50, and when start starts, right, it was moving away because it's X by 5, and change X always means going to right. 5 is always going left. Pause 5 is always going. So it start moves away like that. And when it gets to -465, which is off the page, it would stop completely, right? Right. Now, when I receive loss, it's based on whether these two, whether these two will broad set. And when they cast, win or lose, when it receives it, it would always stop other scripts in this, right? Doesn't matter which one. And the reason I think is because both of these scripts are exact, right? Which is obviously suggesting that it doesn't matter whether this wins or loses, this thing will stop all the scripts. So that's just a detailed analysis of the code. Like you would try to do something like this, right? But this is her thinking when she would create this. Okay, I'm gonna stop sharing my screen. Now it's not great. Okay, yeah, someone will need to share the link. So over here and right here. So I sent the link of the project. Now, to everyone listening, this is just one of many ways to create a Scratch project. And apologies for the bad lesson. we were really uncoordinated as the teacher didn't show up, but this was the best I can do. But as this is the last class, I want to leave you with a word of advice, right? Especially Scratch coding, there are different ways of trying to explain Scratch. And for time reasons, I'm going to explain all the blocks, but I'm going to leave you with this, with a couple tips that might help you in this journey, right? So go through 3 tips. Okay, I'm going to share 3 tips. So tip number 1, the best in Scratch and trying to explore Scratch is the art of debugging, right? So debugging is essentially finding a problem and solving it, right? So it's problem solving. Now, when you problem solve, you would want to first identify the problem, right? So a problem with the jump. So okay, so this is a problem with the jump. Now, what is the problem with the jump? So I look close at the code and I see, okay, so what's wrong? What is not right, right? Step number 2, what I'll do would be to find something that solves it, right? So in this case, if I take a look at the jump and the variable set too high, right? I'll tune the variable down, right? Well, the variable is at 30, I'll turn the variable to 50 instead, right? That way the jump is not that high, or that kind of solves the issue, right? And lastly, you take a look at it again and see if it actually works. Well, it wouldn't always work. And if you find out it still doesn't work, to your liking, you go through that exact same process again, right? And that's the art of problem solving. And that's how everybody in Scratch and professional life, for those who want to actually pursue coding in the future, that's a crucial skill to have, right? Because no matter how detailed you make your code, you're always gonna see mistakes. And when you see mistakes, first thing to do is not to freak out and just throw your hands around. The first thing to do is the problem, solve it, and then make sure it's actually solved. So that's tip number 1. Number 2, I would always suggest you take a look at other people's projects. A lot of times, it's actually with such an open website, it's really hard to figure out how to do something, right? You really need help to do something. There are 2 ways to find out how to do it. 1, look up YouTube videos, or you can look at find books. Number 2, you can always look at other people's Scratch projects and see. Take a bit longer, as you'll have to find what exactly looking at. But as it's not too specific, it's not very hard to find someone else's project that has something that you actually need, right? So many Scratch projects out here. This is a very this platform is going on for ages. There are actually many projects, some of which are mine actually. And you can just go on there and just look at the code and just take a look. Okay, so what did this guy do, right? And look at what this guy did, and you're like, okay, this guy did this, right? Now, actually kind of need that, right? And let me just share my screen quickly, right? And you can use someone else's for your own. And since this is a project, you're totally doing that. Now, let me show you something that might help. Okay, make this a bit smaller. Where's that? Okay, so as you can see right here, right, the code page again, I believe if you were to press some like, where is backpack? Okay, I do need to sign in. You just sign in and confirm your account to get it. Normally, when you have confirmed your account when you are in a Scratch page, see a little tab, you open it, it's the backpack. Now, the cool thing about the backpack is that you can take code from other people's projects and go back to your backpack again. You will see the same you would see that same code you just put into the backpack. Now I can't show you right now, but if you can just do a Google search and see how the back works. Super useful for you to just copy and paste code from one place to another, and that's just be aware that it'll be a very crucial tool when you go on learning to discover Scratch, making cool Scratch. And lastly, I think just challenge yourself, right? Scratch is at first not a very hard platform to understand. There are many people in the Scratch community that have made Scratch extremely complex and difficult. And as long as you are willing to challenge yourself, I'm confident that you all get to that point as well, right? And I think the thing about Scratch is that it can be so easy, but it can be so hard. Right? And playing with Scratch is just like trying a new thing and do stuff like that. Play around. It's like the course. At some point, you will understand new things, and with that new understanding, I'm sure you create some pretty thing, right? And I could see it. So that concludes the end of this class, and I hope you have found my tips useful. Sorry for the not great lesson I gave. It was just impromptu. I had to just think of something on the spot, and yeah, I wish you guys best on in discovering Scratch, and I hope you had fun in this class. Yeah, you guys are free to leave now.